Iwate-Ichinohé Tunnel, 25.81 kilometers, straight through a volatile volcanic mountain. In the late 1990s, Japan attempted what many thought was impossible, building the longest land railway tunnel on Earth.
Look at the strata here, it's shifting. We need to adjust the drill path.
Structural integrity is compromised at section Gamma 12.
But deep underground, the mountain fought back, bending steel supports and threatening to crush the tunnel itself. This is the story of how Japan built the Iwate-Ichinohé Tunnel. By the late 1980s, Japan was extending the Tohoku Shinkansen toward northern Honshu.
One obstacle stood directly in its path: a mountain range stretching nearly 26 kilometers.
Building around it would add valuable time to every journey. Building over it was simply impossible.
Engineers made a different choice.
They would drive a railway tunnel straight through the mountain at 25.81 kilometers.
It would become the longest land railway tunnel ever built. But length was never the greatest challenge. The real battle was hidden inside the mountain itself.
Before excavation could begin, engineers needed to understand what lay beneath the surface.
Hundreds of geological surveys revealed layers of volcanic rock, fractured ground, and groundwater hidden deep inside the mountain. Then they discovered a dangerous 5-kilometer section where the rock had been crushed by ancient geological forces. The question was no longer where to dig. How do you build a rigid concrete tunnel inside a mountain that never stops moving? If the answer was wrong, the surrounding ground could slowly squeeze the tunnel until its structure began to fail. Before the first blast was fired, the engineers already knew they were facing a problem no blueprint alone could solve.
Excavating 25.81 kilometers from only two ends would take far too many years.
Japan divided the project into 7 construction sections. Access tunnels were driven deep into the mountain, allowing multiple excavation crews to work at the same time. Every team advanced independently through different geological conditions.
After each blast, surveyors measured the tunnel's position with extraordinary precision. Even a deviation of only a few centimeters could prevent 2 excavation headings from ever meeting. Progress was tracked constantly as all 7 excavation fronts moved closer together.
All clear. One by one, the distance between them began to disappear. but the most unstable ground was still waiting ahead.
Excavation continued using the new Austrian tunneling method, NATM.
After every blast, workers immediately installed rock bolts, steel ribs, and sprayed concrete to stabilize the tunnel.
For the first several kilometers, everything went according to plan.
Then the excavation reached the fractured volcanic zone.
Groundwater seeped into the surrounding rock. The mountain began expanding instead of remaining stable. In some sections, the tunnel walls moved inward by more than 800 millimeters. Steel ribs bent under the pressure,
and fresh concrete started to crack. The tunnel was no longer changing the mountain. The mountain was changing the tunnel.
Stopping construction would delay the entire Shinkansen project. Instead, engineers redesigned the tunnel while excavation continued.
Thicker shotcrete created a stronger first layer of protection. Longer rock bolts anchored the unstable ground deep inside the mountain. Additional steel ribs were installed where ground pressure was greatest.
Sensors measured movement around the clock. If deformation exceeded the safety limit, excavation stopped immediately.
Every meter of progress depended on real-time engineering decisions.
The mountain tested every solution. Slowly, the tunnel began winning the battle.
Years of excavation brought all 7 construction sections closer together. Surveyors continuously checked every tunnel heading using high-precision instruments.
Each breakthrough had to match the original alignment within just a few centimeters.
Day by day, the remaining rock became thinner.
Then came the final controlled blast. We got a breakthrough. The last wall of rock disappeared. 7 separate tunnels became one continuous 25.81-kilometer railway tunnel. The greatest obstacle had finally been conquered.
Now the empty tunnel had to become a Shinkansen railway.
Breaking through the mountain was only half the project. Engineers began installing the railway inside the 25.81-kilometer tunnel. Concrete slab tracks replaced temporary construction roads.
2 Shinkansen tracks were aligned with millimeter precision.
A 25 kilovolt AC overhead power system supplied electricity throughout the tunnel. Ventilation fans continuously controlled air pressure as high-speed trains passed through. Drainage pumps removed groundwater before it could reach the tracks.
Signals, communications, and emergency systems were tested as one integrated network. Only after every system worked together could the tunnel become a high-speed railway.
Before opening, every part of the tunnel had to prove itself.
Inspection trains traveled through the entire tunnel at increasing speeds. Engineers monitored vibration, track alignment, electrical performance, and tunnel movement.
Emergency lighting, ventilation, and drainage systems were tested repeatedly.
Every result had to remain within strict design limits. A tunnel built for 260 kilometers per hour left no room for error. Months of testing confirmed the railway was ready. Only then was permission given for the first Shinkansen to enter.
In 2002, the Iwate-Ichinohé Tunnel officially opened as part of the Tohoku Shinkansen,
stretching 25.81 kilometers. It became the longest land railway tunnel in the world at the time.
Passengers crossed the mountain in only a few minutes. Few realized they were traveling through one of Japan's most challenging engineering projects. Behind the concrete walls were years of surveying, excavation, redesign, and precision construction. The tunnel connected more than 2 cities. It helped bring northern Japan closer to the rest of the country. And it proved that even a mountain could be engineered into part of a railway. Today, every Shinkansen that passes through the Iwate-Ichinohé Tunnel carries passengers across a mountain they never see. Hidden behind its concrete walls are thousands of engineering decisions that made every journey possible.